So this is a pretty classic use of, like, we're very limited in the things we know how to take the integral of. In the first problem we did, we said that if we have simple little polynomials, we could add 1 to the power and divide by what we get. In the last one, we learned that e to the x dx was e to the x. And so if this x is anything other than just an x, if I have a function within another function, that x makes an awesome u. So that's what we're going to try to trim this down to. So here I've got this whole big function being raised to the third. So my u, I'd like to make x squared plus x. Then you need to take the derivative, so du dx is 2x plus 1, but then we always end up just multiplying by that dx on both sides. So usually we go kind of straight from here to here, kick that dx over on to the other side. And then we go and look, and it's like, oh my goodness, look, that 2x dx is in there. They've carefully rigged this problem for us so that the du is inside the integral, and that'll all be taken care of. This whole thing is just equal to du. And then this is u cubed, just like we planned. And this integral looks like this and is very easy to integrate. Just add 1 to the power, divide by what you get. Because our integral had limits, we do need to be careful. We have 2 options. The way I like to do it is to change my limits. These were when x is 1. These were for x, right? When x is 1 and when x is 2. But when we rewrite our integral in terms of u, we need the limits to be in terms of u as well. So when x is 1, plug it back in, the u would be 1 squared plus 1 is 2. And when x is 2, the u would be 2 squared plus 2 is 6. And so now we can evaluate this limit from 2 to 6 and just plug in the 6 and subtract what we get when we plug in the 2. So it'll be whatever that is, right? And so it's super important that you recognize that the limits aren't the same. You wouldn't get the same answer if you did this from 1 to 2, it wouldn't work. But what you could do if you wanted another way to solve is to put the u back in, x squared plus x to the 4th over 4, and then use since now it's in terms of x, you can use the original 1 and 2. And so notice when you put the 2 in, 2 squared is 4 plus 2 is 6. And 1 squared plus 1 is 2. And you get the same thing, right? So both ways are good to know. Yeah, both ways are good to know. Sometimes you're forced to change the limits depending on what sort of problem you're doing, or if they have sort of like little thinking problems. You have to know this. And some teachers freak out if you accidentally write the wrong limits here. They mark you all wrong. So just be careful with that.